Okay. Assalamualaikum and good evening to our lecturer, Dr. Nik Nur Syahriati, and to my fellow friends. So today, our group will talk about the title, which is compaction in earthworks. So I will introduce our group members first. Okay, Amiruddin.
My name is Amiruddin Samsudin.
My name is Muhammad Jazmi bin Majais.
Hi, my name is Muhammad Ammar bin Hassan.
Hi, my name is Nur Syamimi bin Abdul Rahman.
Hi, my name is Ainshuhada binti Husni. So, okay, start. For the introduction, I will explain generally about compaction, a process to increase the density of soil mass, which it also means, in a detailed definition, it is a process consisting solid particles, air and water, which is the mass of soil is reduced by volume by using mechanical application of fluid, involves rolling, damping or vibration. In this project, I will explain about a few cases which occurred in Malaysia. The first case is excessive foundation settlement and short piles. This case involved in about 40 units of single-story houses and 70 units of double-story houses. So we will observe this, the problems that occurred in this case, which are platform settlement and structural cracking. The second case, platform settlement and wall collapse. This case happened due to geotechnical failures in the infrastructure works and the buildings. The third case is the distortion of building, which is excessive distortion of two-story houses structure. And the last case is differential settlement at bridge abutment. That is all for my part. I will pass to my friend Shamimi to explain for the problem statement.
Thank you, Ain. So I will explain more about problem statement. So we have already identified the factors that contributes to this failure of this project, which is the total or differential settlement due to field self-compression, result in the down drag on foundation piles and alteration of the drainage gradient. So second factors is a collapse settlement upon wetting of compacted field. The next is weight strength. So this is the most crucial part of this project, failure of this project, because it provides necessary flat base which provide the crucial supports for the building. So if the soil is weak, the construction will be weaker and the problem will be occurred in those projects. So next is the high permeability of the field, meaning to say that the water may easily enter on the field, so it weakens the structure of the soil. And if the soil of the strand will be weak with a high permeability due to the presence of the void. Okay, so I will explain the selected cases that I will elaborate more. So first case is the excessive foundation settlement and the short piles. It involved the platform settlement and structural cracks, where the field that used are cut material which impose the pile installation. It is also occurred in an excessive platform, which it caused a serious structural cracks on constructed ground beam, stumps, ground floor slab, and structure. Okay. These are the example of the problems that occur on that project, which it involved the voids underneath the ground beams and also the cracks on the ground beams. So for the case 2 is the distortion of the building, where it involved the excessive distortion of the two-story terrace structures. This is because of the uneven settlement of the platform, which across the longitudinal axis of that structures. It is also because of the tension cracks also occur on the structure frames and wall that were built around them. So, and lastly, it occurs because of the leaking water, subsequently fill material, and it collapsed and the road to the distortion. Next, I will pass the presentation to Jasmine.
Thank you. For the solution and method suggested, for this case, the determined soil types are sand and gravelly soil for this earthwork construction. And there are several suggestions for soil compacted based on type of soils. For type of test, we suggest that to use the Proctor compaction test. Proctor compaction test is one of the most lab compaction tests, the famous lab compaction test, which used mechanical drop rammer to compact the soil. And the result presented in the plot show the relationship between the achieved dry density of compacted soil over the range of moisture content for certain compaction effect. It's like that we have learned in class before. From the Proctor compaction test, we will produce the graph of compaction curve that we will obtain the maximum dry density value and the optimum moisture content value. Next is to use the California bearing ratio. This test is meant to evaluate the mechanical strength of natural ground, subgrades and base course beneath new carriageway construction. And after the establishment of the value of maximum dry density and optimum moisture content of specific soil type, the design engineer then will specify the requirement for field compaction. For sand replacement method process to determine the density or unit weight of the compaction soil in the field, we will use the sand code method, that is to determine the field dry density and to determine the corresponding moisture content of the compacted soil in the field. Okay, thank you. Next.
Okay, next is for the specifications. For your information, there are 3 types of specifications that commonly used in soil, in compactions. Okay, firstly, there are method specifications, end product specifications, and performance specifications. But in this case, in Malaysia, commonly we use end product specifications, which is specifically for sand and gravelly soils. This type of specifications specify on achieve dry density, the ratio, placement moisture content, avoids CBR value or undrained shear strength. Next is there are some aspects that need to be focused. The first aspect dry density. The dry density ratio, which is the ratio of achieved field density to maximum dry density. This is the most common criteria that being used in many earthwork specifications. Next is machinery. There are many types of machinery that can be used, but in this case is we use smooth wheel roller. Sorry, there's no picture. Okay. This machine can form a thin and less permeable layer with smooth sloping surface to encourage surface runoff of rainfall, and it also can reduce erosions and also protect the lower compacted field. And last but not least is moisture content. Okay, moisture content is very important to distinguish compaction from consolidation process. Which is a geotechnical process of expelling pore water from the voids as a result of volume reductions under external static loading on the soil safe weight. Okay, the limits of moisture content during field placements are also vital aspect that need to be specified. Okay. If it's too wet, there will be a risk of excessive consolidation settlement and low strength. Therefore, it is necessary to facilitate compaction and achieve the required dry density. Thank you. That's all from me. Thank you to Daniel. So as the last speaker, I will continue with the result, the conclusion as well as the recommendation. So for the result, as you can see on the screen, the graph for the dry density moisture content and the dry density itself, we can see that at lower moisture content in soil, we result a higher shear resistance between soil grain when compaction. So as the moisture content gradually increase, soil tend to collapse and rearrange easily to a more compact state. So by referring to the graph, we can indirectly find the optimal moisture content. So what is meant by optimal moisture content is the water content at which the dry density is at the peak, at the maximum value. So if the excess water present in the void, the incompressible water acts as a retardant that absorbs and dissipates any compaction energy, thus reducing the compactness. This explains why dry density of moisture curve in most soil types have peaked at OMC, optimal water content, and curve down at both sides of the peak. Zero air void, so by referring to the graph also we can find the zero air void line. So zero air void line indicates a complete saturated soil mass and no part of compaction curve can be beyond zero air void line. But in order to achieve this state, it is too costly and time consuming, and to remove all air void to achieve a fully saturated condition. And furthermore, there is no engineering equipment to achieve this state. So the next slide. So on the screen, these are the failure or the problems that have taken place during the construction. So this failure can be overcome, can be circumvented if you follow the lab test, if you fully follow the lab test given step by step. And also before building any kind of infrastructure, you must the design and the specification must comply with the guidelines given. And the next slide. So to sum up, it is very clear that field compaction has important impact on development with field ground. If not properly addressed during the early stages of project implementation, the consequences can be catastrophic and costly. This has been demonstrated in few case histories presented in this paper. So for the recommendation, it is vital to conduct necessary compaction tests on each type of material sources to establish the target reference for field compaction achievement. The loose compaction leaf should be specified to ensure a minimum dry density within the compacted leaf based on the performance of trial compaction for specific compaction equipment. And there is a need to limit the largest particle size to ensure proper compaction and uniformity of the compactness of field. And the last one, for field test of statistically representative quantity should be carried out to check for non-compliance. Guidelines of testing frequency have been given. And I think that is all from us. And thank you for your time and for lending us your ear. And thank you.